Hi, Integrated Math 1 students. It's Mrs. Robinson back to work practice benchmark chapter 12 with you. Let's go ahead and get started on number 1. This one tells you that WXYZ is congruent to JKLM. Then WX is congruent to which side? So as you can see, this has been a rotation. If you look at the shape of this figure and you rotate it this way slightly, you'll see that, hold on, let me see if I can get this to right. So you'll see that this will line up with J and Z will line up with M. Another way to tell is how it's labeled. So W should line up with J, X with K, Y with L. So if we're looking at WX, it should be congruent to JK. And here's WX, and it should be congruent to JK. All right, on to the next one. All right, here's number 2. It says angle PMN is congruent to what? Now looking at all the labelings, all of these sides are congruent and all the angles are congruent. So this angle would be congruent to this angle based on the markings. You have 3 congruent markings, and here's 2 and here's 1. So if I'm looking at angle PMN, here's PMN, that would be this angle right here. It's going to be congruent to this angle right here. So I would label that angle, since I started with P, where the 2 markings are, I'm going to start with C. So I'm going to go CAB. And that's number 2. All right, looking at number 3, this one asks, given these 2 triangles are congruent to each other, and given that GH is this and RS is this, find the lengths of GH and RS. So let's just draw a free-handed triangle. We don't know the lengths of the sides or the angles. We're just going to draw 2 triangles just to give us an idea of what we're looking at. Label them FGH and triangle QRS. And we're given that GH, this side right here, is 3x minus 2. And we're given that RS is x plus 6. Now, since these 2 triangles are congruent, we know all of their parts are congruent. So this line is going to be congruent to this line. So all we do is set them congruent to each other, or equal to each other in length. We're going to go 3x minus 2 equals x plus 6. And we're going to solve for x. Subtract x to both sides, and that's going to give you 2x minus 2, and that's going to equal 6, and add 2 to both sides. You're going to get 2x equals 8, and then divide by 2, and you'll end up with x equals 4. Now that is not my solution. Careful. Answer the question. It said find the length of GH and RS. So I take 4 and I plug it in for x, and I should have the same value in each one. If I plug in 4 here, I get 4 plus 6, which is 10. If I plug in 4 here, I get 3 times 4, which is 12, minus 2, which is also 10. So GH and RS, sorry, the pen is not working very well. They both equal 10. And that is a 10, even though it doesn't look like a 10. There we go. All right, and that's how you do number 3. Okay, number 4 asks you to name the angle included by the sides of MP and PN. So they just want to know if you know how to label and how to read the sides. Here's MP and here's PN, and the angle included would be angle P. Sorry, angle P. There we go. Okay, number 5 says, what other information do you need in order to prove the triangle is congruent using side angle side congruence postulate? Okay, looking at this, we have these 2 angles congruent, and we actually have a side congruent. It's not labeled, but I know this side is included in both triangles, so it's congruent to itself by the reflexive property. So you have an angle and a side, and we want side angle side. So in order to make that work, we would have a side and angle. We would need this side, and then we have a side and angle, and we would need this side. So what other information do we need? we need to know that BA is congruent to DA in order to make side angle side work. And that's supposed to be a D. And that's how you do number 5. All right, number 6, we're naming the two triangles that are congruent by angle side angle. So angle side angle would be an angle, an included side, and the next angle. So looking at this would be angle side angle. If I could have that same marking on another triangle, I do over here, angle side angle. I know it's these two triangles and not this one, because this one would be an angle. It doesn't have the included side marked. This one would be angle, angle, side. So not this guy. It's going to be these two triangles. So I would say triangle and label it in the correct order with all the parts congruent. So it would go SQR. I have to write it slow or it doesn't like me. Is congruent to triangle. V, since I went S, I'm going to go V, and then to the double marking would be here, VQT. I said Q and I meant U, VUT. And there you have it. Number 7. All right, what theorem or postulate lets you immediately conclude that triangle ABD is congruent to triangle CBD? Looking at this, I have a right angle, which means this is also a right angle here. So I know these two angles are congruent, and they've told me these two angles are congruent. They share this side, so it's congruent to itself. So I would have angle, side, angle in both triangles. So the postulate would be angle, side, angle. There you have it. Next one, 8. Based on the information, what can you conclude and why? So in this one, we're going to use one of these postulates. In this one, we're given angle LOM is congruent to angle NPM. So LOM, it's marked already, is congruent to NPM. It's also marked already. And we're given that LM is congruent to NM. So these are congruent. Now, what else can we conclude? Now, knowing what we know about vertical angles, these two are vertical angles right here. We can mark these immediately. Vertical angles are congruent. So now look what we have. We have an angle. We don't have this side, but we do have another angle and this side. So it would be angle, angle, side. Angle, angle, side. So we can conclude that triangle LOM is congruent to triangle, let's see if I can get this to right, and that's a congruent symbol, is congruent to triangle NPM, and the reason would be angle, angle, side. And I would say that's true by angle, angle, side. And you're done. All right, number 9 asks you, hold on. All right, number 9 asks you what the value of x is. What is the value of x? And looking at this, we can see that these two are marked congruent, which means I have an isosceles triangle. If I have an isosceles triangle, base angles are congruent. And I know a triangle adds up to be 180, and I need to find the value of x. So if that's 64, this is also 64. So I'm just going to go 64 plus 64 plus x. All of these need to add to be 180. I know 64 and 64 is 128. And I need to solve for x. So I'm just going to subtract 128 from both sides. And I know x is, what is that? 180 minus 128. 52. And you're done. All right, next. All right, number 10 is similar. We need to find the values of x and y. Looking at this, it's a little more intricate. You've got Two sides marked congruent, so you'll know that the big triangle is also an isosceles triangle. So you know this is going to be congruent to this. If this is 69, this is also 69. Now this helps me figure out this whole angle. And the beauty of figuring that out is I can cut it in half because I see that these are congruent. So once I figure this out, I can cut it in half and figure that out. So if we do 69 plus 69 plus angle A, that needs to equal 180 for the big triangle, all right? So if we add 69 and 69, we're going to get 138. And then we know that's equal to 180 and subtract 138 from both sides to figure out angle A. All right. So if we do 180 minus 138, we're going to get 42. So we know angle A is 42. Now, knowing that, cutting it at half, angle Y is going to be 21. If I cut 42 in half, I get 21 on each side. If this is 21 and this is 69, I can figure out this angle because in this small triangle, it also has to have all the angles add up to be 180. So to figure out X, I'm going to go 21 plus 69 plus X is 180. And then go ahead and solve for X. 69 and 21 is 90. So I'm going to subtract 90 from both sides, and I'm going to get X equals to 90. So I know X is 90. I know Y is 21. And another thing you could do, assuming this is an isosceles triangle, and if it cuts this in half, you actually are going to know that this is going to drop perpendicular to this side. So this is going to be 90 here because of the perpendicular. However, I wouldn't assume that just yet. But yes, this is a perpendicular. So this does turn out to be 90. All right, on to the next one. Okay, number 11, the wall at the front entrance to the Rock and Roll Hall of Fame Museum in Cleveland, Ohio is an isosceles triangle. The triangle has a vertex of 102. So draw yourself a triangle, an isosceles triangle. If it has a vertex, which would be the top point of 102, we need to find the measure of the base angles. So this angle and this angle. Now if it's isosceles and the vertex is 102, you know the base angles are going to be congruent. So we're just going to go, let's name the base angle X. If this is X, this also has to be X. So there's two X's here. 2X's plus 102 is going to add up to be all of the angles of the triangle 180. Subtract 102 from 180. And then you're going to divide by 2. So bring this down, 2x equals 78. And then divide that by 2 so you can get each x. And you're going to get 1x is 39. So what is the measure of each base angle? 39 degrees for each base angle. All right, is there enough information to conclude that the two triangles are congruent? If so, what name the triangles in a congruent statement? I gotta fix that. If so, name the triangles in a congruent statement. Yeah. And if not, what else would you need to know in order to use prove congruence by the HL theorem? I gotta fix that too. If not, what else would you need to know in order to prove congruence by the HL theorem? So we want to prove congruence by the hypotenuse-leg theorem. Hypotenuse-leg theorem says I have a hypotenuse, so I have a right angle. It only works in right triangles. So I have a hypotenuse congruent to the other hypotenuse, and I also have a leg. So technically, it's the angle side-side, which spells the bad word and we don't use it, but the only way it works is if it's a right triangle. So we call it the hypotenuse and a leg. So is there enough information to conclude they're congruent by the hypotenuse-leg theorem? Well, we know the hypotenuse would be congruent to itself because they share the hypotenuse. So yes. And we have a right triangle, yes, but we don't have another leg. We would either need this leg congruent to this leg, or we would need this leg congruent to this leg. So I'm going to say no. What else will we need to know? Well, we would need another leg congruent to each other. And there we have it. All right, on to number 13. All right, number 13, what additional information would prove the pair of triangles are congruent by the hypotenuse leg theorem? So once again, let's look at this one. We have a hypotenuse and, we have right triangles. And we know this side would be congruent to itself because these triangles share this side. So what we don't have is the hypotenuse congruent to the other hypotenuse. We would need to know the hypotenuses are congruent. So I would say we need to know that the hypotenuse to the other hypotenuse. We'll call it a hypo, right? Or you could simply say we would need to know RT is congruent to VT. That would be a simpler way to do it. All right. On to the next one. All right, what common side do triangles ADC and BCD share? So it's asking for the common side. These are overlapping triangles looking at this. And when you have overlapping triangles, sometimes it helps to do a little highlighting. So here's one triangle right here in yellow, and we'll do the other triangle in red so we can see. And what we're looking for is their common side. So we look for where red and yellow overlap each other, and that's side DC. And then you're done. There's your overlapping side. On to the next one. All right, number 15. Are triangles GHJ and IHJ congruent? So it says 1, state yes or no. 2, if yes, state the reason by side, side, side. All of these reasons you can choose from. If no, state what other information you would need. So I need to do 2 parts to this. I want you to label it. Part 1, yes or no. Well, let's observe. We have this side congruent to this side congruent to this side. It is a right angle. I have these angles congruent here. So I have a lot of ways I can prove these triangles are congruent. I could go side, side, and I know this side would be congruent to itself because it's the same side. So I'm going to say yes, these are congruent. And what are the reasons they're congruent? Well, right here, side, side, side would be a reason. This one has multiple reasons. Just give me one. Side, side, side works. Also, I could have said hypotenuse, leg, because it's a right triangle. The hypotenuse is congruent and a leg is congruent. So I could have said hypotenuse, leg. I could have also said angle, angle, side. That would have worked. Angle, angle, side. I could have said side, angle, side. Side, angle, side. Okay. So side, 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 angle, side. Let's see if angle, side, angle works. Maybe that one even works. Let's look. Angle, side, angle. Yep. Angle, side, angle. So you could have given me any of those reasons why these 2 triangles are congruent. So this one's got quite a bit of information. All right, let's look at 16. Same type of question. Are these 2 triangles congruent? This time it asks you to name the pair of triangles and state yes or no. So let's name the pair of triangles. The triangles that we're looking at would be PEF. Make sure you name it in the correct order. PEF. So if I start here at P, I have to start here at R. Is that congruent to triangle REF? Okay, so there's the pair of triangles. Are they congruent? If yes, state the reason. If no, state what else you would need. So we've got here, these base angles are congruent right here. And we know these angles are congruent, and we know this is congruent to itself. So I would have angle, side angle. So I'm going to say yes. Here's number 1. These triangles are congruent, yes. And part 2, the reason? I think I said angle, side angle, and I meant to say side, angle, side. I don't know if I said angle, side angle, but I shouldn't have. Anyway, side, angle, side would be the reason that they're congruent. All right, 17, based on the given information, we're going to do the same thing. Name the pair of triangles and state if they are congruent. If yes, give the reason. If no, tell what else you would need. So looking at this one, we are given AE bisects BD. Well, if AE bisects BD, we know this would be congruent to this because this line bisected that line. Then we're given that BD, this line, bisects AE. So that means these guys would be congruent. All right. We also see that we have a vertical angle. Right away, you know those are congruent. So I do have congruent triangles. I have side, angle, side, side, angle, side. So let's mark the congruent triangles. Triangle ACE, make sure you name it in the correct order. I said ACE and I meant ACB, is congruent. Since we named the double side first, we come over here and name the double marking side. ECD. Triangle ECD. So ACB is congruent to ECD, and the answer for number 1 would be, there's my triangles, and yes, they are congruent. And the answer to number 2 would be they're congruent by side, angle, side. So go ahead and mark it up, write their congruence. Let's go to 18. Is there enough information to prove these triangles congruent by angle, side, angle? It's specific. They want to know, is there enough for angle, side, angle? If yes, write the triangle congruent statement. So these are congruent and write them in the correct order. If not, write not possible and tell what other information you would need. All right. Is there enough by angle, side, angle? I have an angle. I have a side, but I don't have this angle or this angle. So no, I don't have 2 angles. I do not have enough for angle, side, angle. I have angle, side, side, but that spells the bad word, and it only works if I have a right triangle and I use hypotenuse leg. So the answer here would be not possible. And what other information would you need for angle, side, angle? Well, for this angle, side, angle, I would need this angle right here. So I would need angle J congruent to angle F. And this is what I would need. And there you have it. All right, number 19, which 2 figures are congruent? So this is your transformations here. Let's look at this when we're trying to look at this transformations. Which 2 figures are congruent? If you look at these figures without actually doing distance formula on them, which would take a while to do distance formula from here to here to figure out this length and then this length, let's just observe. These 2 appear to be about the same length, and then these 2 appear to be longer. But look at this figure. This length appears to be shorter than this length. Do these 2 appear to be congruent? Like if this was rotated, this one still appears to be longer than this one. These 2 appear to be congruent, but on this figure, this one appears to be a little bit shorter than this one. So this figure doesn't appear to be congruent to this figure. Let's look at this one. These 2 are congruent, and these 2 appear to be congruent. And over here, these 2 appear to be congruent, and these 2 appear to be congruent. So I bet if I took this and I rotated it this way, rotating it, okay, rotating all the points so it ends up here, and then I pushed it over, it would lie right on top of this figure. So I'm going to say A, B, C, D would be congruent to A, B, C, D. Do it in the correct order. So this segment, if I rotated it around, B would end up here, A would end up here, D would be here, and C would be here. So if I go A, B, C, D, I'm going to go L, M, N, P. L, M, N, P. And those would be the figures that I would say are congruent. All right. Let's go ahead and do the last one, which is a proof. But don't worry about the proof. You will be scaffolded and you will have some choices. So let's go ahead and look at the two-column proof. We got a two-column proof for given MN is congruent to MP, and it's already marked for you. And then NO is congruent to PO. Again, it's marked. We want to prove that angle N is congruent to angle P. We want to prove these two angles are congruent right here and here. All right, so the first statement we always start with is the given. So I'm going to take this and I'm going to restate it. MN is congruent to MP and NO is congruent to PO. Okay, the given. Then MO is congruent to MO. That's the next step they go. Now I like to look at my figure. I'm trying to prove these are congruent. I could get that. If I knew that triangles were congruent, I would know congruent parts of congruent triangles are congruent. So if these two triangles were congruent, then their parts would be congruent. I can easily get these to be congruent because this is congruent to itself. And I would have side, side, side. So the next step they go to is MO is congruent to MO. Well, why? Because of the reflexive property. Reflexive property. All right, and then next, what would I say next? Well, now I know that all the sides are congruent, so I'm going to go ahead and say the triangles are congruent. I'm going to say triangle MPO is congruent to MNO. And that's true by side, 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 which is what we just figured out. Now, because these triangles are congruent, I can say these parts are congruent. So angle N is congruent to angle P because congruent parts of congruent triangles are congruent. And there you're finished. And that is Practice Benchmark Chapter 12. Good luck. Let me know if you have any questions. Have a good day.